China just pulled off a daring spaceflight safety test that could define the future of lunar exploration, and barely anyone noticed. In a remote desert, the Mengzhou spacecraft launched itself skyward in a high-stakes emergency escape drill, proving it's ready to carry taikonauts to the moon. This wasn't just a test, it was a bold signal. China is racing toward the lunar surface, and fast. So what happened, and why it's a game-changer for space travel? When China's Mengzhou spacecraft launched away from its platform on June 17, 2025, it wasn't riding a rocket to orbit, it was escaping one. What unfolded at the Jiuquan Satellite Launch Center in the Gobi Desert was a dramatic and high-speed pad abort test, the first of its kind for China in more than 2 decades. At 12:30 p.m. Beijing time, Mengzhou's launch escape system ignited. Within seconds, it propelled the crew module skyward, simulating what would happen if something went wrong during an actual rocket launch. This test wasn't about reaching space, it was about making sure astronauts could survive if things went terribly wrong just moments after ignition. About 20 seconds into the test, the spacecraft reached its predetermined altitude, separated from the escape tower, and deployed a parachute system. The final touch? A smooth landing cushioned by an inflatable airbag system at precisely 12:32 p.m. Beijing time, just 2 minutes from liftoff to touchdown. While pad abort tests may not sound glamorous, they are essential. They verify whether a spacecraft can perform under pressure and react fast enough to pull its crew to safety. In the high-risk environment of space launch, even a second of delay could mean disaster. That's what makes this success so critical. What's particularly notable here is the evolution in system design. China's older spacecraft, like Shenzhou, relied partly on the rocket to manage emergency scenarios. But Mengzhou changes that paradigm entirely. Now, the spacecraft takes full control of both abort procedures and crew safety. This level of autonomy not only enhances reliability but also shortens reaction times, a vital factor when you're dealing with split-second decisions. And this isn't just about technical achievement, it signals readiness. A country preparing for long-distance crewed missions needs to prove its hardware can protect lives, and that's exactly what this test accomplished. The Mengzhou spacecraft may look sleek and minimal on the outside, but under its surface lies one of China's most advanced crew vehicles to date. Developed specifically for lunar and orbital missions, it's a massive leap from the older Shenzhou design, and it's engineered for far more than just routine trips to space. Mengzhou is designed to carry astronauts all the way to the moon and back, with multiple mission configurations built right in. Let's break down its core structure. Mengzhou comes in 2 distinct variants. The first is a low Earth orbit LEO version, which is partially reusable and built to carry up to 7 astronauts or fewer crew members alongside 500 kilograms of cargo. This configuration will primarily service China's Tiangong space station and future orbital platforms. It's designed to be reliable, modular, and cost-effective for repeated use, something essential for maintaining an active presence in orbit. But the real star is the lunar variant, which is significantly heavier, tipping the scale at up to 26,000 kilograms. This version is built to carry 3 astronauts into lunar orbit, where it will dock with a separate lander. Together, the spacecraft and lander will complete China's first crewed lunar mission, which the country aims to achieve by 2030. Unlike its predecessor, Mengzhou consolidates emergency management systems. Traditional models separated launch abort responsibilities between the rocket and the capsule. Mengzhou, however, takes on full responsibility for abort control, improving the spacecraft's ability to react independently in a crisis. Another key milestone in its development came back in 2020, when China launched a boilerplate version, a simplified test model on a Long March 5B rocket. This mission didn't carry a crew but instead validated Mengzhou's ability to endure high-speed atmospheric reentry, a critical requirement for returning from lunar distances. That test laid the foundation for the version that flew the recent pad abort mission. Taken together, these capabilities make Mengzhou more than a vehicle, it's a platform. It's modular, adaptable, and forward-looking. It has been engineered with both safety and exploration in mind, and its performance so far shows it's more than capable of playing a central role in China's future in space. As development continues, Mengzhou is quickly becoming the backbone of a new era in crewed Chinese spaceflight. With Mengzhou proving itself through critical tests, the next question becomes, how will China actually get astronauts to the moon? The answer lies in a carefully coordinated launch architecture, and it's already well underway. Central to this plan is the Long March 10, China's next-generation crew-rated launch vehicle, and the Lanyue lunar lander, which together will form the transport and landing system for China's first human moon missions. The Long March 10 is not just a scaled-up rocket. It's a brand-new vehicle with deep space capability. It features three 5.0-meter diameter core stages, powered by YF 100K kerosene liquid oxygen engines. These engines are derived from those used on the Long March 5 but represent a refined, more powerful version. The entire rocket is being designed to support the heavy mass of the Mengzhou capsule and its service module during lunar injection missions. It's also intended to meet international standards for crewed launches, with rigorous safety margins built in. Construction of the Long March 10's launch facilities is already underway at the Wenchang spaceport on Hainan Island. This is a coastal site, chosen for its proximity to the equator, which provides an extra velocity boost for rockets heading to the moon. It's also where other heavy launch platforms like Long March 5B operate, streamlining logistics and infrastructure. Supporting the crew will be the Lanyue lunar lander, a spacecraft that will be launched separately and placed in lunar orbit ahead of the astronauts' arrival. Once Mengzhou docks with it, the lander will descend to the moon's surface with 2 or 3 taikonauts aboard, while the command module remains in orbit. This strategy mirrors the successful approach used during the Apollo missions but uses modern, modular technology. Importantly, China's lunar program appears to be gaining speed just as other programs face delays. NASA's Artemis 3 mission is currently scheduled for 2027, but future Artemis missions may be affected by budget revisions. The proposed U.S. 2026 federal budget even calls for the cancellation of further Orion spacecraft and SLS launches after Artemis 3. That creates an uncertain timeline for continued crewed lunar missions from the U.S., and gives China a potential opening. China's roadmap is ambitious, but it's also methodical and grounded in real progress. Every piece, Mengzhou, Long March 10, Lanyue, is being built with interoperability and mission success in mind. So what did we learn from a 2-minute test in the middle of the Gobi Desert? Quite a lot, actually. China just proved it has a fully functional crew escape system, a next-generation spacecraft ready for lunar travel, and a launch architecture that's unfolding with precision. While the world watches Artemis wobble, Beijing is accelerating with fewer headlines, but sharper execution. Whether or not China puts the next human on the moon, one thing is clear, they're not just aiming for orbit anymore, they're aiming for history. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, spaceinews.com. Thank you for watching, and see you next time.